Good morning. Good morning, all. In today's class, we will learn analysis of the algorithm. The term analysis of algorithm is associated with algorithms efficiency with respect to execution time and memory usage. It's nothing but program performance. The program performance is measured by the efficiency of the program in terms of memory required to execute and the time needed to run the program. The efficiency of the algorithm depends on two factors, namely the memory used and the execution time. Memory used is nothing but space efficiency and execution time is the time efficiency. In some applications, the main constraint will be memory, and in some other applications, the main constraint will be time taken to run the application. So, we concentrate both on space complexity and the time complexity. The space complexity is the measure of minimum amount of memory which is essential to run the program completely and efficiently. And time complexity is the time taken by a program to execute completely. The time taken the time TP taken by the program P depends on the compile time and the execution time. Since a program can be compiled many number of times, we concentrate only on the run time or execution time to find the complexity. That is, time complexity is the amount of time taken by the program to run to completion. We will concentrate only on the run time, and we estimate the runtime of the program based on step count and the operation count. Step count is the number of times each statement is executed in the algorithm, that is time spent by each statement while executing the entire algorithm is the step count, and operation count is the time taken or the most important or key operation in an algorithm is identified, and we compute the number of times the key operation is executed. This is called as the operation count. The time complexity depends on the number of inputs. We may be interested to note that time complexity as the input value increases, that is the time taken by a program increases as the number of input also increases. For example, it takes larger time or longer time to search in a larger array, and more time is required to multiply larger matrices, etc. The efficiency of the algorithm, which is measured by using time, we concentrate on the step count and the operation count. While calculating the step count, so for some of the problems, data time complexity will not depend on the number of inputs alone. For example, while searching for a specific item in an array of n elements, the item we are searching may be present in very first location, or may be present in the maybe not present in the array. So, knowing n alone itself is not enough to estimate the runtime of the algorithm. In such cases, the operation count or step count can be obtained by considering worst case, best case, and average case. Worst case is the maximum number of steps required for execution for a given input parameters. Best case is the minimum number of steps required for execution for given input parameter, and the average case is the average number of steps required for execution for given input parameters. So, the time complexity also depends on the input also. Now consider, for example, we move the order of growth. What is an order of growth? As the value of input increases, as the value of input increases, some algorithms take less time and some take more time. So algorithm which take less time can be chosen. And many algorithms use this n as the parameter which affects the running time very significantly. The parameter n may indicate the number of elements in the array to be sorted or the searched, the length of a given string, and so on. Most of the time, the value of n is directly proportional to the size of data to be processed. So, the resource requirement of our program, especially the time, is also expressed in terms of n using some mathematical formulas that are simple as possible and as accurate as possible for large value of n. The algorithms that we deal typically have running times proportional to one of the following, like constant. If majority of instructions in a program are executed once or very few times, we say that running time of a program is constant. And next is log n. It indicates that running time of a program is logarithmic. As the value of n increases, runtime decreases. This running time occurs in programs that solve larger problems by reducing the problem size by a constant factor at each step. Example, binary search. Next, n. N indicates the running time of a program is linear. When n is 1000, the runtime is 1000 units. When n is double, so does the running time. Next, n log n. N log n indicates that running time of a program is n log n, which means that this running time occurs in algorithms that solve problems by splitting the problem into number of smaller subproblems, solving these subproblems, and finally combine the solutions. Problems such as quicksort, merge sort, etc. will have this runtime. Next, n square indicates that running time of a program is quadratic. The algorithm which uses this running time are practically used when value of n is relatively small. Next, n cube indicates that running time of a program is cubic and is practical for small problems. 2n and n factorial indicates that running time of a program is exponential. Most of the problems with this time complexity naturally use brute force technique to solve a given problem.